There we go. Okay, so today is about two things. One, inverses, because remember me saying that these are inverses? One of them's an exponential, one of them's a log. And they make an inverse because if I make this dotted line at y equals 1, or sorry, y equals x, like right there, then that shows that these are inverses of each other. All right, so that's one theme for today. The other is to actually graph things like there's a log base 2 of x, and a couple things about the graphs. First of all, if I have a bigger base, like if I did log base 12 of x, then that would still have the asymptote right here, and I'll make that blue maybe, and then it goes much tighter, like that. If it has a bigger base, it makes a sharper turn. Okay. All right, how about base e? Well, do you have an approximation for e in your head? It's about... Oh, memorize this because ln means log base e, and if you don't know what e is, you don't know what log base that is. Log base e is about 2.718, and I know that's obscene. 2.7 is just fine. E is about 2.7, okay? But it's one of those numbers that goes on forever, never repeats, also known as a, starts with an I, irrational number. Okay, good. So back to this. So if I have my log, which is now taking a super sharp turn because I gave it a base of 12, the bigger the base, the sharper the turn there, it still goes through this spot. Let's talk about why the heck would it always, when you put in 1, why would it always be at 1, 0? Because you just won the argument. You see how we put the 1 right there, and then what does it have to be? 0. When you put in 1, it has to go through that spot. Unless you move the whole thing over. If you move the whole thing over, it won't equal 0 anymore. But 1, 0, 1's there, and I could say equals 0 over here. 1, 0 is a thing on the log graph where it'll always go through this spot unless you have moved it over, like this. Not a square root, just a log base 3 of x, and if I want to move it to the right, I go like -3. Do you get that would move the whole thing to the right 3? Do you get if I put a +5 here, it would go also up 5? Okay. Now, when this thing moves to the right 3, do you get it's going to drag the asymptote with it? It'll go over to 3. All right, so another important spot to find is where the asymptote is. I want you to go off to the side and write this one. Y equals log base 2 of x. And if you're graphing today, I have told you that you don't even need to know what the parent graph looks like. We just reviewed it, but you don't even need to know that. Because you have your best friend in graphing, the what? XY chart. Everybody make me an XY chart. And we're going to pick a few things, and we're not just going to be like random. We're going to be strategic. We're going to pick things that'll be smart to pick. So what would be smart to pick for x? 1. 1's really smart because you instant answer. If you won the argument, you get nothing. 1, 0. Boom, I'm done. What if I can make this argument here into 2? Why is that a smart call? Because these bases match, and then the answer must be the exponent, which would be 1, 2, 1. Is 3 a good call? No. Here's why. If I put a 3 here, log base 2 of 3 is some weird decimal, and I don't know what it is, so I wouldn't be able to get the y. So I would just skip over 3, and I would try something else, like 4. And 4 is particularly good because 4 is the same exact thing as 2 squared. So the bases match again. So the answer is the exponent, which is 2, 4, 2. And one more valuable one that you can always look for is, can you make the base number but 1 over the base number? So log base 2 of x is what I'm graphing, and I got to pick something for x. And what if I could make this into 1/2? Why would that be smart? It's going to make you think. 1/2 is a good call. Now, some of your people are just saying the answer. Don't just say the answer. What could you then turn 1/2 into that will make everybody see what the answer is? 2 to the -1. That's the same thing as 1/2. I know a lot of people have forgotten their fraction exponents and their negative exponents, but this is an important one. 2 to the negative 1 is the same as 1/2. So then you really put in 2 to the negative 1, which is 1/2. You put in 1/2, and now what's the answer? Negative 1. That's the answer. So we put in 1/2, which is the same as 2 to the negative 1, and we got negative 1. Now, do you get, I have 1, 2, 3, 4 dots there. If I can't figure out what this graph looks like from those 4 dots, there's one other thing I could do that would be smart. Leah, could you shut the door, please? One more thing we could do that would be smart, and that would be to find where the asymptote is. I have a very simple way of doing that. You take this part right here, I'm highlighting it, this part right here, and you figure out what makes it 0. In this case, it's almost too obvious. What makes that part 0? 0. So 0, I know I can't put in 0. But why can't I put in 0? Because it won't exist. And in the way it happens to not exist is it gives us the asymptote. If there is 0 there, it gives us the asymptote. All right, now here's the challenge. Can you take that same set, and I know if you graph these now, well, duh, it'll be super easy to do. There's an asymptote at 0. I can graph 1, 0. I can graph 2, 1. I can graph 4, 2. It looks a lot like a square root there, doesn't it? And then I can graph 1/2, negative 1, which is like down here. And look, if you can't connect those dots and figure out where the graph goes, I have no hope for you anymore. Like, duh, it goes here. So if you get 4 dots, you'll have enough to know where the curve is. Okay?
Yeah, I was going to say.
All right, so now I want you to see if you can extend that now to what if it's a little more complicated. What if it's y equals log base 3, and not just of x, let's make it of x minus 2. Now, we want to find an xy chart, just like before. And what was one of the keys? If you could make this part right here equal 3, then you'd have log base 3 of 3, which would be easy, right? So what should you put in? 5. Do you get what he was thinking? Put in a 5. 5 minus 2 is 3. Then I have log base 3 of 3. And what is log base 3 of 3? 1. Because this part here turned into log base 3 of 3, which was 1. Okay, what would be another smart thing to put in? I want to remind you, and I strongly recommend that you take notes on this in some way. This one was the one you always make x equal 1. You always make x match its base. You always make it the base squared. You always make it a fraction of the base. And you always figure out what makes the argument 0, and that'll be your asymptote. If we can do that on every single one, you'll have plenty of points. So let's make this part, the red part here, into 1 so that I can 1 the argument. So what do I got to put in to make it be 1? 3. Because then I'll have log base 3 of 3 minus 2 is 1. That's log base 3 of 1, which is 0, because I won the argument. I want you to see if you remember those other ones. I gave you examples. What would be others? You can just bumble around and pick things like, well, I'm going to stick in 2 and see what happens. Oh, that actually worked out to be a good one. But if they don't work out, try other things. But look especially hard for the one that would make this turn into log base 3 of 1/3. Because that is one of the hardest ones to find. And it's one of the ones that'll be like going down. Like, you know, most of the dots are up here. Doot, 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 doot. It'll give you one of these precious dots that's going downwards like this. Okay, so try to figure out what makes the argument part turn into 1/3. You can totally use decimals or fractions in your XY chart to be able to do that. Okay, Leah, tell me something you put in and what it turned into. You put in 11. I wasn't expecting that. But now I see why. 11 minus 2 is 9. And then what did you say the answer was? Log base 3 of 9, which was 2. Very good. Okay. Mariam, tell me something that we could put in and what it gives us. If you're stumped for one here, just put in 2. If I put in 2, what do we get then? Log base 3 of 0, that's a special spot, gives you the what? Asymptote is correct. Okay, so we got an asymptote and 3 points. We just need one more point. Owen, what's the point? You don't know it? Okay. This one's a little tougher because you got to figure out how to make this turn into 1/3. But, oh, you got it. What is it? 7/3. Now, you're being fancy by saying that as an improper fraction. Could you have said 2 1/3? That'd be the same as 7/3, right? So if you wrote it as 2 1/3, that's the way I'd think of it. Because when I put in 2 1/3 and I take away the 2, I end up with 1/3. 2 1/3, and then that gives you this, and then that's -1. Raise your hand if you had 2 1/3 or 7/3, comma -1. Okay, good. Do you see how we have 4 points and the asymptote? And from there, you got to get it right. Like, you'll figure it out. Okay. Cool. We are almost done with the lesson for today. It's that fast, and that's good because we can hand your tests back and stuff. But there's another little review part where we got to go over a bunch of basics because you're going to be doing these all the time. What if I had log base 3 of 9? What's the answer? 2. Do you know why? Because the 9 is really like 3 squared. And then the answer is the exponent. Okay, good. What if I had log base 3 of 1? 0. Why? Because you got a 1 in the argument. If you wanted to say equals x, you might be able to then quick do a rewrite in your head and say 3 to the x equals 1 if you need to like piece it together and go, oh yeah, it must be to the 0 power to make it equal 1, so it's 0. Okay, the next one I want you to know is log base 3 of 27. 3. Because this is really 3 to the 3rd. All right, the next one I want you to know is log base 4 of 1/4. -1. Because that one is really 4 to the -1. If you didn't get that before, process that. Make sure you get that. Because see how now I write it that way, duh, the answer is -1. Okay. 1/4 can be written as 4 to the -1. All right, next one. Let's say I had this. Ready process. Do you get, I want to make that 4 into a 1/4 to a power. So it'll be 1/4 to the something. So 4 is 1/4 to the -1. So then the answer is -1 again. All right. Okay, so there's some of the most common ones that you just have to recognize. And the last but not least is, what if I had a typical log base 3 of x plus 7, and that's in the argument spot. And then they say, I want to know what the inverse of that is. Well, in fact, honestly, at first I was like, crap, I don't remember how to teach this. And then I was just, and I went one little step at a time and said, okay, what did I do on inverses again? What's the whole point of inverses? There's a change between, what gets changed around? X and Y get changed around. Like the domain becomes a range becomes a domain, right? So, tell me what to do. change x and y around. So this becomes x. And then, once I realized it was just switch x and y around, and it was like, oh, well, this isn't going to be that bad. I know it looks weird, but what do you think we should do? Can I just leave it that way? Is that the inverse? No, it's kind of close, but now I need to solve that somehow for y. And when you're solving, the key is always rewrite it. Remember the circle of logs? Three is the base. To the, now you got to go to the other side, x, and then you come back, because y plus 7. Remember, you're trying to solve for y, so one more little step. Come on, what's the last step? Hello? Anyone? Anyone? Bueller? 3 to the x minus 7 equals y. Does that look like an equation to you? If you were to graph it and the original one, you would see, oh, here's my log that I had in the first place. I'm going to graph it over here. Here's my log. And wait, it's been moved 7 to the left, so it would look kind of like that. Get that's a log that's been moved 7 to the left. And then this one, if I graphed it, it would be an exponential that's been moved. What? Wait a minute. It's been moved down 7. Double checking myself here that I haven't lost my mind. Nope. Haven't lost my mind. Y equals 3 to the x minus 7. Then here's my exponential. And it's got to move. Oh, I see what I did wrong. It's got to be moved 7 to the left, so that's moving it 7 down. That minus 7 needs to be in the exponent. So where did I go wrong when I rewrote it? That. I just need to graph this for a second. I'm going to pause and I'm going to graph it. So here's the part that was hurting my head. I knew that the black log was in the right place. And then I was thinking about how the picture usually kind of looks like this, where there's the one here and the other's over there. Okay, right? They're a reflection across the line y equals x. And so they're always, they never are crossing each other. That's what I was kind of thinking they should look like. But if you take the black one and you say, where's the line y equals x? Just a second here. And you say, where's the line y equals x? It's right here. And now I have to do a reflection across that line. And now my exponential is going to look like that, which is 3 to the x, but shifted down 7. So yay, it actually all works. It just, in my head, I couldn't see that reflection across that line. And now I see it, and now I know I wasn't misleading you. You just switch the x and y around, and then you solve. Follow up.
So that kind of answers my own question, but when you do a translation, you move it like up or down or left or right.
Yep.
It still the reflection line still says y is
Yep.
y equals x.
Yes, it does. It's always the reflection line is always y equals x. Okay, so let's just do one where you get I get you a nice clean log base 4 of x minus 1, and I'd like you to tell me what its inverse is. So Noah, what's step 1? So I already have an equation. So I switch. I don't think you know. Do you know what to switch? Okay. Because this is the big deal about inverses, is that x and y switch around. Okay, domain becomes a range, range becomes a domain. Okay, so x and y get switched. All right, so this x goes away and this y goes away, and I change it into x and then y. Okay, Mariam, what's the next step? A little louder, please. Yep. 4 to the x. Very good. Keep going. Y minus 1. Okay. Saloni, final step. Add 1 on both sides. 4 to the x plus 1. And I like my y equals to be on the left. You can do that. It's no big deal. It was technically here, but you can obviously put it on the other side. This looks more logical to me. There it is. There's my inverse. See how that's pretty easy? Swap x and y. Solve it by rewriting it. Cool. Now you know everything. Now let's go and find this page that's got the little like finger on it. You should be able to snap off these answers in literally 1 minute. On your mark, get set, go. I bet you you'll do it in less than a minute. Raise your hand when you're done. I just want to see them pop up and like, okay, I got 2 people done already. 3, 4 people done. Now how many people done? All right, in 30 seconds, we got about half the class. Okay, now you can put your hands down. The rest of you guys finish up. Okay, check with the kid next to you and see what they think the answers are.
Oh wait, yeah, because it is 0. Okay, no.
Shawnee, you want to compare with Owen? Talk. You already have? Just compare the first couple. We got to get going. All right. Carter, I heard some kids say there's no solution for the first one, and I kind of agree, but I kind of disagree. The first one here, that they said there's no solution, and I kind of agree, but I kind of disagree. What do you say? It's the asymptote.
What do you think you were going to get it from?
So, yep, it is the vertical asymptote, and it's better than just not working. Do you get it? Still, it doesn't work. That's the point of an asymptote, is that nothing works there. But it's a special kind of not working, because this part right here is 0. Okay, the next part is where you won the argument and you get nothing. Raise your hand if you had a 0 there. Good. Next one is these match, so the answer is 1. And then the last one is where this is a fraction, exact flip of that, which means it's like a to the negative 1, so it's -1. Raise your hand if you had all of them right. Sweet. Okay. Now, this is where I'm supposed to explain about exponential growth, so I think it's good for me to talk about that. Would you agree that exponential means that basically you have something that has an x in the exponent? That is exponential. Notice there's no log involved. It's just an exponent. Okay. Now, can we make it have a log involved? Well, sure, because anytime you have an x in the exponent, you could rewrite it as a log. All right. I'd like you to see if you can figure out from your recollection of exponentials, what goes here, then what goes here, and then what goes here. I'm going to pause for a second. You did this in higher algebra. You did. You had exponential graphs, and there was always something that would go here, something that would go here, and then something that would go there. See if you can do it. I'll pause for just a second. Okay, to put you out of your misery, you may or may not remember this. This is where the starting value goes. This is where the ending value goes, like how much you have at the end. This is where you go 1 plus the rate, let's say that you're growing by like 50%. And last but not least, this is where your time goes. As in, it's usually x. So I'll give you an example that is not from this problem. It's like back from when you were in higher algebra. Let's say that there's around 4,000 moose. I did the research. There's around 4,000 moose in Minnesota. Sadly, they had been shrinking lately, but they've been starting to grow again. The population has been growing again. So let's say that it grows by 7%. And I just put an x here for the time. Do you get that? I had 4,000 to start with. They're growing by 7%. X is the time in the number of years. Or it could be in months, or it could be in whatever. But this is however often it's growing by 7%. Do you get that in 1 year? We could multiply by 1.07. If there had been 1 year, you'd multiply by 1.07. It makes it grow a little bit. Does that make sense? Okay, so let's do that. Just that same problem, but let's say that we said that the number of moose was gonna double. Well, you wouldn't add 1.07. What does doubling mean for a growth rate? Would you agree that's growing by 100%? Which is like adding 1 here, which is like this is 2. Doubling would mean that's a 2 right there. So then, again, this would be insane for moose, but if you had 4,000 moose and they were doubling every year, do you get how that would be like that? And it would be a problem, yes. I mean, actually, if it happened just for 1 year and then they stopped doing that, it'd probably be okay. We could probably handle it. But in the long run, in the limit, we'd all be wading through moose to get to our school. Okay, so what if, this is the important part, so pay attention. What if they were doubling, but it wasn't every year, it was every 3 years? What do you think I should mess with? The time. And if it's doubling every 3 years, then I'd put divided by 3. Because then if I put in a 3, you know, like it's been 3 years, I put a 3 here? And then it would be like it's to the power of 1, and then it would give me a double. Does that make sense to you? All right, so then here's the key. This right here is how, if you're taking notes like you should be, often it doubles. Because sometimes we'll have it's doubling every 10 minutes. Because bacteria can do that kind of thing. Nope, I can't tell you that. It's not public information, so I have to be careful. All right, I was just going to use a good example that I can't use. So let's do a different double. How about we go to the problem that's actually on the board that we started with, this one. We got 1 nasty microbe, so we have a start value of 1. So you start with, I want to leave my notes on the screen though, so I'm going to go above the problem. 1 nasty microbe, y equals starting value of 1. Is it growing? Yes, it doubles. Do you get that's 1 plus 100% growth? That'd be the same as a 2, of course, but I'm writing it separately. Good. Now I'm going to say it doubles every minute. Do you get if I just say x is minutes, then I could just say x, and I'm done. What if I had said it doubles every 2 minutes? Then it would have been x over 2. What if I'd say it doubles every 5 minutes? X over 5. Getting the idea? All right. Okay, so we've got this 1 nasty microbe, and it's 8 a.m. and it goes till 5 p.m. They probably did that because it's like a work day. During that work day, I went from 8 to 5, which is how many hours? 9 hours. Wait a minute. Yeah, you're right. 9 hours. So during that 9 hours, well, it was doubling every 1 minute, and I put in a 9 here. Then do you get that it's going to double 9 times? So now I got to do 1 times 2 to the 9th. That's how many microbes would be.
When you post it,
Uh-oh, obviously made a mistake. I'm going to let Martin say what's wrong.
Every 60th of an hour.
Doubles. Oh, it's hours. Oh, okay. Yeah, my bad. Okay, it's doubling every minute. I got messed up. It's a classic. I had all the right numbers, but the units were messed up. Okay, so this is x. And do I really have to put x divided by 1? No, it's the same thing as x. But it's in minutes. So then, when I went and slapped in my 9 happily right there, I should have put in 9 times, now there's 9 hours times 60 minutes is 540. Holy crap, it's almost like the number of microbes could just get out of control. Yes, it can. There are things that hold it down. They just, as new research, this is kind of interesting to me. You know why you get sick more often in the really cold weather? You know, like the cold and flu season. It's in the winter. They just did research on this, literally, like just came out like within the last 2 days. I try to stay fresh on interesting stuff like this. They figured out that super cold weather destroys things in your nose that are good at fighting off bacteria. Do you get a lot of the bacteria you get and that give you a cold comes through your nose? And super cold weather destroys that down to 50% of its strength. So, if you're in like Hawaii, you don't have as big of a cold and flu season because it's beautiful in Hawaii all the time. So here in Minnesota, it just proves we shouldn't live here. All right. Because when it's really cold, it hurts your nose capabilities of stopping infection or not stopping, what's that? Not really called infection. Stopping you from getting a cold. And they said it actually didn't take that many degrees. It doesn't take like super sub-zero temperatures to make your nose way weaker at fighting off bad stuff. All right. All the more reason, though, to not pick your nose. Because you're jamming microbes up in there and extra loading it with, like, your nose is trying to fight off the nasty stuff that's coming in. So I know you probably didn't need another reason not to pick your nose, but you got one anyways. All right, so I don't want to deal with this right now. I think we've done enough for today. So we're going to go to this. If I asked you to graph that, I hope you just go, ooh, 2 to the x, except where did I move it? Is that up 1 or is that left 1? That's really what you got to ask. That will be to the left 1 because it's up in the exponent. Do you get if it had been a plus 1 on the outside over here, then it would have been up 1? And it matters. That little plus 1 is up with the x. The stuff in with the x is horizontal on the inside. So that meant the thing didn't move up 1. It moved left 1. Remember, high horizontal on the inside and vo. Any change you make here or here on the outside are verticals on the outside. Okay. All right. And if you had to, and you totally had forgotten what these even look like, an XY chart would have saved the day. You would have graphed, let's say, 4 points in the asymptote. The asymptote on these go across at 0, and then you would have graphed a few points, and if you can't connect the dots, you probably shouldn't be an honors pre-calc. Okay. On to actual homework. Let's get there now. It looks like this. I recommend that you do this problem and skip that problem. I recommend that you skip this problem. I recommend that you do the first one here and that you skip these 2. And I recommend you find a couple of inverses. So let's skip these 2. And you may skip that one too. And if there's anything after that, you can skip that too. All right, that cuts it down to a much more reasonable sized assignment. And that's all I have for the video for today.